Our next topic is about 9.2 and 9.3. And 9.2 is about the graph. You guys will learn how to draw the graph, and at the same time from the graph you want to write an equation on how to use the equations lah. And then the last part you learn about a period. Okay, so we're going to focus on 9.2 first, which is about graph. Okay, let's see if I give you an example. Not example lah, just a revision. Okay, if I have a graph of maybe y against x, let's say if my graph is something like this. Okay, do you guys still remember kalau kat sekolah kan kita belajar graph macam ni, equation dia macam mana? You guys still remember tak?
Saya ingat dia sign je.
Okay, sign. Good, very good. Yang lain ada nak tambah apa-apa selain daripada sign? Dia apa sama dengan apa? Tak ingat eh?
Tak ingat lah sir.
Tak ingat dah sir.
Okay, don't worry. Okay, so this one is actually y graph. Okay, so this is actually y equals to something sine x. Okay, and then this one is multiplied with the amplitude a. So the height of the graph will be represented by the amplitude a lah. The bigger the number, that means you have higher graph. Okay, and at the same time, supposedly in front of x here you have a constant. Okay, so that constant biasanya dia tak tekankan dalam dekat sekolah tu, biasa dia letak nombor terus lah, contoh macam 2x, 3x, 4x. Okay, those number actually will affects the period ataupun dia punya jarak wavelength itu. So the bigger the number, you expect that the graph would be bigger, macam dia melebar. Kalau numbers are very small, then you expect this one is very small as well, something like that. So that's the general idea lah, but we don't want to focus too much about that. So first thing first, just want to focus on the shape of the graph. Okay, so the first graph is a sine x, and instead of using y and x, maybe I can change to something more related to our current chapter lah, which is about x and t, where x normally in meter and t normally in second. So we're gonna write this one as x. The y-axis tadi kan jadi x, and then yang dalam sini instead of x kita ada t. Okay, and that constant yang kita tulis tadi tu, I'm gonna put this as omega. Ingat lagi tak semalam, omega is equals to apa?
2 pi over t.
Yes, it's a 2 pi over t ataupun equals to
2 pi f.
2 pi f, yes. So you expect lah, the bigger the frequency, that means the omega is bigger. Yeah? So like I told you before lah, bigger frequency means that it is much more closer. Yeah? Kalau period, short period, maksudnya satu oscillation tu cepat je. Dah, 0.1 second, 0.2 second, 0.3 second. Okay, itu maksudnya daripada physical meaning. Okay, let's try to look at a different example. Okay, let's see if I have a graph that looks something like this. If I have a graph something like this, what function should I use? What trigonometric function? Is it still sine or is it different?
Negative sign kan sir?
Yes, very good. It will be a negative sign. So everything else is the same. Okay, you still have the amplitude A and negative A like previously. So it will be A negative sine omega t. So negative here means that the graph is actually flipped on the x-axis. Okay, so if you guys don't remember, kita belajar lah, don't worry. Kalau dah belajar, masih ingat, That's good lah, don't worry. And then we have another types of graph which looks something like this. Graph apa tu?
Cosine.
Cos.
Cos, yes, ataupun cosine lah nama penulis kan. So we write this one as x equals to a cos omega t. So you can see that everything else is the same. A and omega remain the same. The only thing changes over here is the function. So we have sine, negative sine, cos, and then the last one obviously we have negative cos lah. We shape something like u tu tapi terbalik. So masa dekat sekolah tu cara saya nak hafal lah. Kalau yang sin tu dia nampak macam huruf S. S sin S. Yang cos tu dia adalah U shape. Cuma kalau negatif tu dia terbalik. It's basically flip on the x axis. Okay. Sorry, I think I'm gonna rewrite this one as well. Lupa nak tukar. Sebagai x and t. X meter t second. Okay, why these things are important? Kenapa kamu kena tahu those things? If you guys still remember, yesterday we learned about a general formula for displacement. Where x is equals to a sine omega t. And as you guys learned yesterday, this one plus 3, the values for a, omega, and phi can change, right? And I told you before as well that the sign can change as well. It doesn't have to be sinusoidal lah. It could be sine, it could be cos, it could be negative cos, and it could be positive cos. So the reason why you need to understand this is that you can choose the correct formula for this one. Okay, imagine soalan yang pertama sekali, you have to determine these things. Kalau benda ni salah, that means when you calculate the velocity, when you calculate the acceleration, everything will be wrong as well. Kalau ditanya yang pasal time tu lah. Kalau ditanya pasal yang displacement tu, kalau kamu pakai fixed formula tu tak ada masalah. Saya tunjuk balik Going back to yesterday, in case you guys forgot. Kamu pening, tutup mata sekejap. Okay, like this. Okay, so like I told you before, this is the first step. Okay, so we start yesterday from sine. So it doesn't have to be sine. So in case you start from cos, then below here will be difference lah. Follow up with this one. So if the question is about this one, then you have to be really careful when you try to determine the equation. Okay, but if the question asks you to use this one, then it doesn't matter pun. Okay, this one tak ada pakai sin, cos ke apa. Ini equation ni sentiasa valid for all simple harmonic motion. So kalau soalan dia pasal ni, then you survive lah, tak ada masalah. Okay, but if the question is like this, you have to be really careful. Okay, kalau pening tutup mata. Kalau saya pening, tengok tulisan laju ni pening. Okay. Now, going back to here, let's see if I give you an example. Okay, so the question will want you to write the displacement against time equation. Okay, so they give you example in terms of storyline. Dia tak kasih pun diagram, dia cerita. Dia kata a mass is being hang on a spring. Dia kata mass digantung dekat atas spring. So you can imagine dia tergantung macam ni lah. So if I leave it like this, okay, basically the mass will be hang at equilibrium. So maksudnya dia dekat equilibrium lah. Net force dia sama dengan zero. Dia balance, dia dah tak bergerak, dia hanging by itself. So that position we call as x equals to 0. Okay, but now before the experiment start ataupun before situasi ni berlangsung, dia kata the mass is being pulled maybe 2 cm below the equilibrium position. Ataupun dia tak cakap pun below. Dia kata the mass is being pulled 2 cm from the equilibrium. Tapi kita faham lah, kalau dia kata pull, kalau pull tarik ke bawah ke atas? Which one is pull? Adakah ke bawah ataupun ke atas? Mana yang betul? Is it
Ke bawah.
A or is it B? Ke bawah kan? Kita pull mass, kita tarik dia ke bawah. Dia, kalau ke atas tu dia panggil apa?
Push.
Push.
Push, yes. Okay, so dia normally dia tak cakap tau. Kalau spring ni biasa dia tak cakap ke kiri ke kanan ke atas ke bawah. Most likely they will use a term like push and pull, compress or regang apa yang regang? Stretch, sorry. So kalau dia tarik dia akan pakai term stretch lah, maksudnya pull. Kalau push, compress lah, dia tak pakai push ke bawah, dia pakai push ke atas, something like that. Okay, anyway, dia kata this object is being pulled 2 cm from the equilibrium. So now your situation change a little bit. Okay, daripada sini maybe dia dah berubah lah, dari ke bawah 2 cm. Okay, so let's say this one is x equals to 2 cm. Positive ke negative?
Positif.
Kalau below equilibrium,
Oh, below negatif.
yes, negatif. Kalau atas positif, kalau kanan positif. So dia sama je macam dulu. Atas positif, kanan positif, kiri negatif, bawah negatif. So in this case, the below equilibrium, so negative. Okay, then dia kata when the timer start, the object is being released. Okay, so initial position dia dekat mana? Adakah dekat A, dekat B ataupun dekat C? Guys, kat mana? Initial position dia, maksudnya bila dia lepaskan dia daripada mana? Daripada bawah A ke B ke C?
Daripada C.
C. So sebab dia lepas kat bawah lah kan, takkan tiba dekat A pula. So the moment dia lepas tu, that is when the T is equals to 0. So dekat bawah sini T is equals to 0. Let's say if I want to plot inside my graph over here, should I plot it over there, or over there? A, B, C. Mana satu? A, B, C.
C.
C. Okay. Sebab dia start daripada bawah. So you're gonna start from down here. So saya tukar colour sikit. Okay. Sebab apa dia start daripada bawah?
Kenapa C? Tapi time dia 0, kenapa tak B?
Kenapa tak apa? B.
Kenapa tak B? Sebab time dia 0.
Okay, dia sebenarnya kena ikut jalan cerita dia. Sebab jalan cerita dia kata initially tadi dia dekat equilibrium. Lepas tu dia ditarik ke bawah. Okay. Lepas tu dia kata bila dia lepaskan, then only the timer start. At the moment dia lepas tu timer tu start. So before that timer tak start lagi. So T equals to 0 bila dia dekat sini. And then T equals to, the start counting tu daripada sini lah. Understand ke tak?
Oh, okay. Faham.
Okay. So bila dia gerak, dia akan gerak ke mana? Ke bawah ke atas?
Dia gerak ke atas.
Ke atas lah kan? So bila dia gerak ke atas, eventually dia akan pergi dekat equilibrium tu. And then as time goes by, dia akan pergi naik atas sampai ke atas ni. Kamu rasa dia naik sampai mana? Berapa sentimeter dia naik?
Sampai 2.
Sampai 2. Because of the conservation of energy. There's no energy loss. So bila dia tarik tu, basically you apply some work lah. You put some potential energy into the system. And then when you release, energy yang sama. So maksudnya kat sini and over here, that will be your amplitude. Dia akan naik dekat sini dengan kat sini je. Naik turun, naik turun, naik turun. Dia tak akan tiba-tiba pergi ke bawah. Okay, that's one thing. And then lagi satu, kalau ikut logik, dia akan slowly berhenti kan. Itu kita panggil dia damping lah. Tapi damping tu tak ada dalam syllabus kamu. So we assume that the energy is conserved. There's no energy loss. So it will start to move and will remains moving like that sampai bila? Tak ada time limit, dia akan sentiasa naik turun with the amplitude of 2 cm. Faham ke tak?
Faham sir, faham.
Okay, good. Yang lain? Okay.
Okay, sir.
Right.
Okay,
Okay,
sir.
sir.
So I can label this one as 2 and -2. So it will goes up and down, and you will have a graph that looks something like this. Okay, kalau saya panjangkan lagi, dia panjang lah macam tu lagi. Okay, tapi saya buat satu je dulu. So once it goes from here, and it goes up, and it goes back, let's say the time taken is 1 second lah. So that one is your period. Okay, for one complete oscillation, dalam soalan cakap lah, the time taken is 1 second. So if you want to draw the graph, the displacement against time, this would be the graph. Okay, you need to label the amplitude. Don't forget to put the -2. Ramai student terlupa letak negative tu, and some student dia terlupa terus letak kat bawahnya, dia label kat atas je. And then lagi satu kamu kena label period ni. Okay, you have to label. So x axis, y axis macam biasalah, y axis, x axis macam biasa you have to label, and then information amplitude and period you have to label macam semalam lah kita discuss. Okay, ini untuk lukis graph. Okay, from the graph you can write down the equation, betul?
Betul.
So ni graph apa ni?
Negative cos.
Yes. So you should write x equals to -a cos omega t. And if you guys really want to substitute the numbers, then the a would be 2. Okay. And then the omega you have to calculate lah, equals to 2 pi over t, which is equals to 2 pi over 1. Then you get 2 pi. Okay. Katakanlah kalau kamu nak tulis, jangan rengkap. Okay, but now for this time, my main purpose is that I just want to show that this one is a cos graph. Okay, the situation dia macam ni. Dia tarik daripada bawah and then dia lepas. Okay, kalau kamu positive cos, maksudnya dia daripada atas and then dia release. Okay, and most of the time untuk spring ataupun untuk pendulum, the situation would be something like this, sama ada dekat negatif ataupun kat positif. Kalau dia start daripada zero tu, maksudnya objek tu dah memang bergerak, dia dah memang going up and down, up and down, and then dia kata when it is at x equals to 0, dia start the timer. Okay, that's when you have t equals to 0 dekat sini. Kalau tak, dia memang takkan start daripada tengah tu. Itu je. Okay, so you have to read the question carefully. Jangan gopoh nak buat, baca dulu sampai habis. Try to draw a simple sketch. Okay, because it is really important for you to determine the sign ke cos and then positive or negative. Kalau pendulum, kamu tengok lah, dia tarik ke kiri ke tarik ke kanan. Kalau spring yang horizontal, push ke pull ke, you have to really you have to consider all those things lah. Tak boleh simply cakap oh dia sign. No, it could be different. Okay, now let's say if you really insist that you want to write it in terms of this, in terms of sign, boleh ke tak? The answer, boleh. So trigonometric, dia ada identity. As you guys know lah, maksud saya identity tu, dia ada few equation, nama dia berbeza ataupun bentuk dia berbeza, tapi jawapan dia sama. So the same case happen also over here lah. So you can write this one in terms of in terms of positive sign omega t, tapi you have to put a phi. Okay, the phi could be positive, the phi could be negative, and the phi you have to determine. Macam mana nak determine tu? Okay, you have to look at this equation lah, this graph, sorry. So this is a negative cos graph. Kalau saya cakap negative cos graph ni sebenarnya adalah a sine graph that has been shifted. Kamu percaya ke tidak?
Percaya sir.
Kena percaya lah kan, tak percaya lah.
Percayalah.
Basically, cos ni adalah sine graph yang telah bergerak. Okay, contoh katakanlah saya ambil pembaris And let's see if I draw, saya potong dekat sini. Okay, so basically I ignore belakang ni. Does it look like a sine graph?
Yes.
Yes.
So it is actually a sine graph. So basically we use that concept. So bila kita gerakkan dia, kita shiftkan dia. So kita potongkan graph tu, axis dia tu kan, kita potong ke kanan by pi over 2. So positive pi over 2. So you have to substitute inside here with a positive pi over 2. Kenapa pi over 2? Okay. Betul saya letak. Okay, let's say you have a graph like this. Okay, the length of the whole one oscillation, actually dia buat satu complete cycle. So that one is what we call 2 pi. Okay, so half of that is actually pi. Quarter of that is actually pi over 2. And then more like 360 degrees, 180 degrees, and 90 degrees. But we don't write this one in terms of degrees, we write in terms of radian. So that's why you have something like this lah. Kalau this shifted by 2 pi, that means 2 pi lah. Kalau half pi, so pi. Kalau this one is pi over 2. So tadi kita discuss dekat sini je, dia bergerak. So going back to here, so basically dia gerak sini, so pi over 2, it's a positive pi over 2. Okay, ada soalan tak so far?
Tak ada, sir.
Tadi sir.
Okay, kalau
Ada,
saya
sir.
nak potong, okay, katakan saya nak potong dia belah kiri, boleh ke? Tadi saya potong hijau tu, saya potong kat kanan kan? Saya nak potong kat kiri?
Maksud sir macam ni? Tak faham.
Kalau saya nak potong belah sini, boleh?
Tak ada apa-apa kat situ, so tak boleh lah kan?
Tak ada apa-apa. Kalau saya panjangkan graf saja,
Oh,
adakah
Kalau
dia
saya
jadi
extrapolate boleh kot.
boleh.
Kan?
Dia akan jadi sine lah kan. Sabar.
Betul?
Dia akan jadi sine balik lah.
Betul?
Tapi dia negatif sign.
Ya, saya pernah. Betul. Okay, so katakanlah. Sekejap. Takut saya tersalah tunjuk kamu je. I think saya terbalik saya rasa. Dia bukan positif, dia negatif. Okay, to check whether this one is correct or not, kan? You can do a simple calculation. Okay. So, if I want to do a simple calculation, let's say if I choose a number. So, let's say x equals to cos 4.5 pi dengan x equals to sin 4.5 pi plus pi over 2. Okay, if you calculate the first one, make sure your calculator is in radian. Berapa kamu dapat? Maksud saya negative cos 4.5 pi tadi, berapa kamu dapat?
0.
Zero.
Zero Okay, tukarlah tak nak zero. Okay, change this one to 4.8. Okay, this one shouldn't be zero. Okay, yang bawah ni pun saya tukar pada 4.8. Kalau zero tak nampak pula sama ke beza.
Okay, dapat 0.81.
Positif ke negatif?
Positif.
So dia negatif kan, so positif 0.809. Okay, yang bawah tu
Negatif 0.81.
So this one negative 8, 0.809.
If 0.1.
Kan?
Ah,
Jawapan
yeah.
dia tak
Yes,
sama.
yes.
Sebenarnya salah lah ni. So this one sepatutnya negative. I always got confused with this one. Jadi saya explain kenapa saya confused. This one should be negative. So that means kalau kamu potong ke kanan, bila nak draw, it will be negative. Okay. So cuba kita try lagi sekali. Kalau ini negatif dapat tak sama? 4.8 pi tolak pi over 2
Dapat positif sir.
dapat positif So this one is the actual identity lah. Okay, so dia sebenarnya saya selalu confuse bukan apa tau. Sebabnya bila saya belajar gerakan graph. So I actually move the graph, okay, gerak ke kiri dan ke kanan. And bila saya masuk matrix, student dengan pensyarah semua dia pakai gerakan axis. So I got confused sebab yang satu tu dia terbalik dengan yang saya belajar lah. So it's either one. So that's why sometimes I got confused. So it's okay. Dalam exam kalau kamu confused, you can always double check exactly macam kita buat just now. So that's not a big problem pun. You can always double check. Kalau it makes sense lah. And then kalau yang sambung saya cakap tadi, kalau kita extrapolatekan graph ni ke belakang, so this one actually eventually it will look like a sign as well kat belakang sini, betul?
Yes.
And then
Yes.
this one actually you can also move the graph, move the axis ke belakang. So here you will get a positive. This one is basically separuh pi. So if you move from here to here is pi over 2. And then you move extra separuh belakang lagi which is pi. So you get 3 pi over 2. Ataupun pi tambah pi half lah. 1.5 pi. So at the same time, you can also write this one as x equals to a sine omega t plus 3 pi over 2. Okay, to check whether this is the same or not, you can always double check down here. Okay, berapa dapat? Sekali tekan.
.809.
Sama So
Sama.
you get the same answer. So basically these three equation is the same thing. Okay, they represent benda yang sama. So it backs to the initial question lah. So buat apa kamu nak buat bawah ni, betul? Kan? So let's say they give you a graph, they give you a situation, okay, and then kamu dah draw, you draw dia punya pergerakan semua dah cantik, and you determine dia punya ni sebagai ini. So you can leave it like that. Okay, boleh biarkan dia sebagai cos. You don't have to change. Okay. Tapi kenapa saya nak kena ajar juga benda ni? Sebab kadang-kadang dia kasih equation ini and dia suruh kamu lukis. Okay. So dia terbalik sikit. Tadi yang kita belajar tu, kita dah lukis, lepas tu kita tentukan equation dia. So kalau kamu sendiri yang tentukan equation, there's no reason kamu nak ambil risiko untuk tukar and then salah macam saya buat tadi. Okay, tapi sometimes ada setengah soalan dia kasih kamu equation ni, lepas tu dia suruh kamu lukis bentuk graf dia. So in that regards, you really have to know lah nak potong dekat mana. So dia terbalik sedikit. Kalau yang macam ni, katakan kamu daripada sini kan, so maksudnya dia kasih equation yang ini, yang tengah-tengah ni. So basically kamu kena start draw daripada sine graph. So basically you draw a sine graph like that. Okay. Lepas tu dia kata potong dekat negative pi over 2. Sekarang ni kamu potong dekat belah kiri pi over 2. So it's a little bit different. So I'm going to show you. in the next page. Sebab tadi daripada graph kamu buat equation, now daripada equation kamu nak buat graph, so it's a bit different lah. Contoh if I give you example, x equals to a sin omega t, katakan plus pi over 2. Tadi kita buat minus kan? Okay, tadi kita buat minus, now we're gonna do the plus. So what you guys need to do, first thing first, you draw the axis macam biasa. Okay, and then you draw the shape of the original sign tu, so it will be something like this. Okay, and then tambah pi over 2 sebenarnya kamu potong dekat sini. Okay, so you get a positive cos graph. So you can see that this one is actually x equals to a cos omega t. This is the same. Sama je. Faham ke tidak?
Faham sir, faham. Okay, okay.
Yang ni memang sangat senang, sangat simple. Cuma dia terbalik dengan yang saya tunjuk tadi. Perasan tak? Yang kalau tadi positif dia ke kiri, yang ni positif dia ke kanan. Okay, so untuk mengelakkan kekeliruan, yang this one actually kamu tak perlu buat daripada macam ni tau. Most likely kamu nak apply bila dia kasih macam ni. So dia kasih kamu equation, kamu yang potong dia kat belah mana. So kamu yang tentukan nak potong kat mana lah. So positif tu ke kanan lah, senang ingat. Kiri negatif, potong. Kalau positif, potong dekat belah kanan. Okay, I'll give you another example so that you guys okay with it. Okay, x sama dengan a cos negatif. Okay, katakanlah kita susahkan sikit. Negatif cos omega t minus pi over 2. Okay, pertama sekali kamu nak bikin graf apa?
Graph cos. Negatif.
Okay, graf negatif cos. Yang lain okay?
Okay, sir.
Okay. So this is a graph of negative cos. But your actual graph, you have to consider this part lah. So nak potong dekat belah kiri ke belah kanan? Kalau negatif, potong kiri kanan. Kiri Kalau positif tadi, dia potong kat belah kanan. Kalau negatif, dia potong belah kiri. So kiri ni nak potong kat mana pula? Tak nampak kan? So sebab tak nampak, kamu kena panjangkan sedikit. Okay, kalau dia pi, kamu kena panjangkan banyak lah. Tapi sebab sekarang ni dia hanyalah pi over 2, so I think this one is enough. So your graph kamu potong dekat sini. Okay, so your actual graph sebenarnya bentuk dia macam mana?
Negative sign.
Yes, correct. Okay, I hope you guys are clear with this. Dah lama dia tak suruh lukis. Most likely dia akan kasih situation and they ask you to write down the equation. Biasanya macam tu. Okay, tapi ini more to like the old punya syllabus, dia selalu tanya, dia selalu suruh kamu lukis. Okay, the last part dia ask you to draw lah. So kalau draw ada face different, you have to be careful a little bit. You have to consider lah yang part ujung ni. Okay, ada soalan tak?
No sir, tak ada soalan.
Okay, maybe nanti kamu jumpa soal, kamu cuba buat tutorial ke apa ke, maybe kamu akan nampak masa bila nak pakai this thing. Okay, okay, now 9.3 sebab period. Okay, period ni dulu student a little bit confused because kamu ada 3 period sebenarnya dekat dalam syllabus kamu untuk semester ni. Yang mana? Period yang pertama tu sebenarnya kamu jumpa masa dekat gravity punya period tu. Ingat tak? Satellite motion tu. Ada R cube.
Okay, okay.
Okay, and then period yang kedua dan ketiga ni is more like for simple harmonic motion, which is about pendulum and Spring. Mana saya punya ni equation? Okay lah, lupa. So this equation is given in formula sheet, so you don't have to worry. Okay. Kalau dulu dia tak beri, so student confused period yang mana. Tapi kamu jangan hafal T tu semata kan, jadi nak terpakai satellite punya equation pula. Okay, cara nak bezakan antara period untuk pendulum dengan spring, spring ni dia ada K. K here represent the spring constant. So M is a mass, hanging mass lah. K is a spring constant. So as long as you have a spring constant, you straight away know that this one is for spring. That undergoes the simple harmonic motion lah. And this one is the period for pendulum. And then if you guys remember ataupun aware, the experiment that you did is that basically you try to prove this equation tu.
Betul sir.
Betul, sir.
Where the period, the time is took for one complete oscillation depends on the length of the pendulum. Lagi panjang, lagi lama lah tempoh dia. So it makes sense lah. Derivation ada dalam nota, but you don't need to, it's not in your learning outcome, so I'm not going to show you. But you can study yourself. So length of pendulum. Dulu lah, dia pernah tanya sekali, what happened when the pendulum, the experiment is being conducted on the moon, at the moon, sorry. Dia tak buat dekat bumi, dia buat kat bulan. So you will expect that the gravity will be less kan. So what happened with the period? Okay, itu soalan yang pernah ditanya lah dulu-dulu. And then biasanya kalau soalan ni sebab dia simple sangat, if they give you information at the length, you can straight away find the period, right? So to make things interesting, biasanya lah dia akan tanya relationship. Okay, contohnya macam ni, period T is directly proportional with the square root of L, and it inversely proportional to the square root of G. Over here, T is directly proportional to the mass, ataupun T is directly proportional to the K. Okay, sorry, 1 over K. Okay, K here represent the spring constant. If you guys are not aware, lagi tinggi K, actually dia lagi keras spring tu. Okay, maksud saya, kamu boleh bayangkan kamu nak tarik spring, kalau susah nak tarik, dia K dia tinggi. Kalau dia lembut, maksudnya K dia rendah lah. So kalau kamu bayangkan kamu gantung benda dekat spring yang lembut, kamu tarik dia, kamu lepaskan dia, dia pergi dia tu laju ke slow?
Dia pergi laju.
Slow.
Pergi slow, lagi lebih slow.
Dia lembut, kamu tarik dia panjang, lepas tu kamu lepas. Dia gerak laju ke slow?
Slow.
Slow kan? Betul?
Slow.
Okay, dia akan gerak slow lah. Kalau kamu tak percaya, kamu kena cubalah. There's no other way. So try cuba, kamu boleh bayangkan. So dia akan gerak slowly naik, slowly turun. Slowly naik, slowly turun. So it means that when the K is lower, the period, the time taken to complete one oscillation will increase. So it makes sense. Kalau dia keras, kamu tarik, lepas dia macam kan, dia naik turun laju. So that one is a less T. T dia semua lah. Okay, apa lagi saya nak cakap? Lupa dah. Okay, macam saya cakap tadi, dia tak semestinya dia kasih numbers kan. Tapi spring ni kadang-kadang dia kasih number. Okay, contohnya kalau kamu nak cari nilai K, dia biasa tak kasih nilai K tu, dia suruh kamu kira nilai K. So if they didn't give you K, kamu kena baca soalan dia. Masa dekat equilibrium, masa dia tengah balance, kamu akan dapat force ke atas dengan weight ke bawah sama balance. Ini spring Maksudnya bila dia balance ni, dia tak ada daya luar. Dia by itself, dia akan static dekat equilibrium tu. Itu adalah bila dia balance. So weight yang tarik dia ke bawah, ada satu force tarik dia ke atas. Force tu sebenarnya adalah restoring force daripada spring tu. We call this one F restoring lah. Dan banyak simbol, kadang-kadang dia pakai FK, kadang-kadang dia pakai FX. I want to put FX. Okay, FX here is KX. Okay, FX tu formula sama dengan KX. So what does it mean? Why this one is that summation of Fy is equals to 0, where Kx equals to mg. Okay, this sebenarnya Fx minus weight equals to 0, and then I can bring the weight to the other side. I got Kx equals to mg. Okay, and then only you can find the K. So you have to have the information, what is the position when it is being put at equilibrium. Dia dibiarkan dekat equilibrium, X dia berapa, and then you can straight away calculate dia punya K, and then only you can substitute inside this equation. Okay, biasanya spring kamu kena buat macam tu. Okay, kalau pendulum dia akan suruh kamu buat relation. Contohnya kan, dia kata initially the length of the pendulum, let's say is L. Okay, after that the length of the pendulum is being double. What happened with the period? So T yang pertama, what is the relation between the final period dengan the initial period? Tu maksudnya lah. So macam tu, macam yang biasa saya tunjuk perkadaran lah. Ambil formula tu, saya tunjuk kan, kamu masukkan je. So maksudnya initial T dia, T yang asal, L dia tu kamu substitute sebagai L besar. So you leave it like that. T yang baru, yang mana dia pakai L yang baru, then it will be 2L over G. Lepas tu kamu nak buat apa ni? Ingat lagi tak? Saya biasa tunjuk. You want to compare with the initial one. Okay, so basically kamu factorkan nombor yang pelik tu, yang baru ada tu lah. Macam tu. Okay, and you can see clearly that this one and this one is basically the same. Okay, so I can substitute back where T prime is actually equals to square root of 2T. Okay, kalau pendulum biasanya sebab dia senang sangat, biasa dia macam tu lah. Dia kasih soalan macam ni, dia tak kasih any numbers, dia akan sebut dalam ayat. Katakan the length is being triple, the length is being cut into half, what happened with the period. So you have to state macam ni, selesaikan dia macam tu. Kalau yang spring pun sama, kalau dia kasih the K is being changed to a higher K, then you have to change lah, tukar je, double the K. Okay, ada soalan tak?